Let us see some example. Example 1. Two bodies A and B of mass m and 2m respectively are placed on a smooth floor. They are connected by a light spring of stiffness K. This is the spring constant. A third body C of mass m moves with a velocity v0 along the line AB and collides elastically with A. If L0 is the natural length, L0 is given, natural length of the spring, find the minimum separation between block A and B. Now what is going to happen? This C will come and hit elastically. Both the masses are same. So they will exchange their velocities. Now C will be at rest. Block A starts moving. Block A, when it moves, the spring gets compressed. You want to know what is the separation minimum between A and B. So what we will do first here, we will calculate, or first we will take the elastic collision between A and B. For elastic collision between body C and A. What are the velocities of this body, first body and the second body? Let us calculate. Velocity of C will be m1 minus m2 by m1 plus m2 times of u1 plus you have 2m2 divided by m1 plus m2 into u2. Let us substitute in this. m1 is m minus m by 2m into u1 plus 2m divided by 2m into u2. u2 is 0. That is the velocity of body A. So finally we get this velocity as 0. So velocity of C after collision is 0. What about velocity of A after collision? Again we can use the formula of elastic collision. 2m1 by m1 plus m2 times of u1 plus you have here m2 minus m1 divided by m1 plus m2 into u2. So this will be 2m divided by 2m into u1 plus you have m minus m divided by m plus m into u2. u2 is 0. So what you are going to get it over here as u1. So what will be the velocity of A? It will be the velocity of first body, that is C body, that is v0. So due to elastic collision, these two masses will interchange the velocities. So as the collision is elastic, body C is brought to rest and body A starts moving with speed v0. Now body A is moving with v0. Body B is at rest. Body C is brought to rest. Now as it moves forward, the spring gets compressed. Now there is no external force. So whatever is happening between A and B, that will be due to the internal force. Let us see in the next slide. Now what we concluded, body A is moving with velocity v0 and body B is at rest. Body C is brought to rest. So understand the situation very carefully. Now I will take it only body A and B. This mass is 2m, this mass is m, and they are connected by a spring of natural length L0 and constant K. Now it starts moving with velocity v0. This is at rest. Okay. So no external force is acting. This point you remember. So what will happen? This body as it moves forward, I will show you one more picture here so that you can understand. This body B remains at the same position. Okay, because its velocity is 0. But body A, since its velocity is there, it will move forward. Since it's moving with velocity v0. Now what happens? This spring will compress. As the spring compresses, spring constant is K. What the spring will do? Immediately it wants to go back to its natural length. So it will apply a force on B. That force will be F is equal to Kx. X is the compression in the spring. Also, if the spring will apply a force on A, that force F is equal to Kx, trying to come back to its natural length, that is L0. So this force which is spring is making it to act on body A and B. It is an internal force and still there is no external force acting on the body. So the speed of this body is v0. The speed of this body is 0. See the direction of this force F is equal to Kx. Because of this force, body B starts from rest. Now it starts moving. Whereas the direction of this force is in the opposite direction to point A. So the speed which is v0, now v0 will decrease. And here the velocity will increase. So did you follow this point here? No external force is acting. Only the force is the internal force, that is F is equal to K. So due to this Kx, body B will start accelerating or experience an acceleration and it will increase its velocity from 0. Whereas this F is equal to Kx is acting in the opposite direction. So body A will, which has initial speed as called v0, will try to decrease its speed. and its speed, suppose V naught is 10 meter per second, now it becomes 9 meter per second. Whereas the body B has 0 meter per second, now it becomes 1 meter per second. So the velocity of body B goes on increasing, velocity of body B goes on decreasing. But still, velocity of body B is 1 meter per second, velocity of body A is 9 meter per second. Body A is moving faster than body B, the spring will contract more. So suppose if I show you this in another picture here, then you will understand how the bodies are going to move. Now body B has got some velocity, so body B starts moving, but its velocity is very less. Body A's velocity is decreased, but it is more than body B, so it's moving faster than body B. So therefore the spring will contract more. So are you following this point? Since it starts from 0 to 1 meter per second. This is from 10 to 9 meter per second. But still 9 meter per second is greater than 1 meter per second. So spring will contract more. So it will apply greater force on B and apply a greater force on A. Thus this force value, as X increases, this force value increases. So the speed of this body will increase rapidly. The speed of this body will decrease rapidly. After some time, when it decreases from 10 to 9 to 8 to 7, here it increases from 0 to 1 to 3 to 4, like that. After some time, we will see, since no external force is acting, finally what we are going to get is body A and B both now move with the same velocity, right? So the speed of this body, suppose, is V. The speed of this body also will be V. So using law of conservation of linear momentum, since no external force is acting, what do you get? M, mass of the body A, into its speed V naught is equal to, now they are moving together with a common speed called V. M plus 2M, let me call that speed as V. So we can get the value of V, that is the common speed which is there, that is V naught by 3, where V naught is the initial speed of body A. We want to calculate minimum separation between block A and B. Minimum separation between the block A and B means L naught is the original distance. Now how much the spring has compressed, if I take it out, we get the minimum distance. To calculate the compression, let us use law of conservation of energy. Law of conservation of energy. If X naught is the maximum compression, then initial kinetic energy is half mv naught square. Now the kinetic energy, since they are moving together, m plus 2m into common speed v square plus some energy stored in the spring as called half k x naught square. So what are you going to get? Half of mv naught square is equal to half of 3m into this velocity we know, v naught square by 9 plus half of k into x naught square. So solving, we get x naught is equal to v naught square, we'll take it out of root as v naught, 2m by 3k. So what is the minimum separation? Minimum separation will be, suppose d is equal to L naught minus x naught. L naught is the initial length of the spring. So L naught minus x naught, v naught under root of 2m by 3k. So here what we have used? Here 2 or 3 things we have used. First, we have taken elastic collision from body C onto body A. So body C will be brought to rest here itself. Body C does not move. Why? Because collision is elastic, they exchange their velocity. Now this body starts moving with velocity v naught, whereas this body is at rest. The spring will get compressed. As the spring compresses, it will apply a force on B as well as A. So the velocity of this body starts increasing, whereas the velocity of this body will decrease. Since the velocity v naught after decreasing also is greater than the velocity of body B, the compression in spring will go on increasing. As the compression in the spring increases, this velocity will manifold increase, this velocity will manifold decrease, and the compression of the string will continue till they acquire a common speed. So since no external force is acting and the force which we have taken here is the internal force only, finally both the bodies A and B now move with the same velocity. Since no external force is acting, let us use law of conservation of linear momentum between body A and B. M into V naught is equal to, because they are moving now with the same velocity, M plus 2M into capital V. We have calculated that common velocity. Now maximum compression we want. So law of conservation of energy. If X naught is the maximum compression, half of mv naught square is equal to, we can use the kinetic energy of the combined system plus the potential energy of the spring. Easily we can calculate value of X naught. Minimum separation will become L naught minus X naught.